Okay, so continue students again. Question number 8 says which of the following statement is true for real number? So the first says product of these three makes 1. So let's check that, please. As you see, sin x, cot x, sec x are written. So you have to remember the property of cot x. I mean how cot x was defined, sec x also defined. So you need to recall that. So sin x times cot x times sec x. This is basically the same as sin x is written as it is, but cot x, as we know, is a ratio between cosine and sine. So you just write that as it is. And then sec x follows, and sec x is 1 over cos x. So students, as you just simplify this, you will obtain this value, what, being 1. The student here, had I been in place of you, I just have, selected A alone and without checking, you see, the rest, because I don't need to spend my time doing or checking the rest. But if you check the rest, students, all the rest alternatives are not right. Let me just try to show you that. If you come to B, it says 1 minus cosec squared x is cot squared x, but this is not cot squared x, students. Using the trigonometric identity, this is negative cot squared x, so negative must be introduced here, so B is false. And when you come to C, sin 2x is 2 times sin x cos x, but what has been written here says sin x cos x, so C is not right. And when you come to cos 2x, basically this is equivalent to 2 times cos squared x minus 1. From trigonometric identities. So again, what has been written here is something different. So the answer is going to be A in the case of question number 8. So proceeding to the next one, question number 9, it says which of the following is true about the hyperbolic function for each real number x, it says. So when you come to the first one, A, we knew that cosine hyperbolic x is defined as e to the power of x plus e to the power of minus x over 2. And sine hyperbolic x is defined as e to the power of x minus e to the power of minus x over 2. So when you compare these two, obviously, ignore these denominators. Look, here is the sum of two positive terms. You see the sum of two positive terms, whereas here the difference of two positive terms, obviously the left is greater than the right, so cosine hyperbolic x is greater than sine hyperbolic x. So this is true, but what has been written here is sine hyperbolic x is greater, so A is not right. So we ignore A and we directly go to B. We knew that tan hyperbolic x is the ratio of sine hyperbolic x and cos hyperbolic x. So as you take the ratio of the two, you will obtain this expression, students. E to the power of x minus e to the power of minus x over 2. In fact, it was over 2. Again, we were having over 2 again here, but 2 can be cancelled by 2, and then you can have this, right? Yeah, you can have this. So as you are substituting 2 ln 3 here in place of x, it will be tan hyperbolic of, you see, 2 ln 3, but we knew that from logarithm property 2 can be taken up and then ln 3 square can come, which actually is ln 9. So now a matter of plugging ln 9 here in place of x, it's a matter of putting that and simplifying it. Very simple, students, as you are substituting ln 9 throughout x expression here. E to the power of ln 9 is 9, and here this minus can be taken out, and then 9 to the power of minus 1 is 1 over 9, right? And this minus directly comes from this one, and here is the power of, I'm putting ln 9 throughout in x, so this will be 9 again, plus, and this minus goes up, and 1 over 9 is going to come, so as you see, you have this. So the next task is a matter of simplifying this. This is very simple. 9 with 9, 81 minus 1, it is 80 over 9 divided by, this is 81 plus 142 divided by 9, 9 can be cancelled by 9, and then you do have 40 over 49, students. But what has been given here is 65 over 63, which actually is not right, right? So B is not again selected. But again, when you come to C, y equals sine hyperbolic x is a periodic function. No, it's not like that, students. Beloved ones, you have to know that sine hyperbolic, cos hyperbolic, these hyperbolic functions are not periodic. That is to say that we don't have a definite interval where everything is going to repeat that. and like that of trigonometric functions. Okay, so these functions are not periodic, so C is not right. But when you come to D, the cosine hyperbolic of minus x is the same as cosine hyperbolic of x, because even if you may put minus x, you see you can obtain the same output. And we knew that the range for cosine hyperbolic x is, you see, 1 to infinity. That is to say, this graph is great, or this function is greater than or equal to 1. So what has been written in D is right. So the answer is going to be D. So when we go to the next one, question number 10, it says, which of the following is a point that trisects the line segment with endpoints 2, -2 and -7, 4? So this is talking about dividing a line segment internally. So again, you need to recall how it can be done here. So the solution goes like this. So what you need to do is you have to first take x1, y1 as 2, -2, directly taken from the given information. So you may take x1 to be 2 and y1 to be -2, and x to be 2, -7, and y to be 2, 4, as you see. And then our interest is to find places where these line segments can, can be divided into 3 equal parts. So we must expect 2 different points for this to happen. So here you can have R1 to be 1 and R2 to be 2. So proceeding to the next, we have this one. Look here, the idea is like this. So the endpoints are here. You see, the first endpoint might be here, the other might be here. So we're now dividing this line segment into 3. So this is the first part, this is the second part, this is the third part. So we are going to now look for these 2 points, either this one or this one. So what I'm now going to do is, you see, 1 to 2 ratio. That is to say, I'm going to find this point. But you have to, again, you may not obtain, student, you may not obtain this one being written here in the choice. If you are unable to obtain this one, you have to again look for this. You see, you don't know what has been given here. You see, if we are lucky enough, we may obtain the first point here, over here. Here I took R1 to be 1 and R2 to be 2. If you are unable to obtain, you see, the final obtained points here in the alternative, you have to interchange these two, okay? To may come here in R1 and one come in R2. In such a way, you have to do that, because the point written here in the choice might be a point of this one or this one, depends on the type of, you see, the point given in the alternative. Anyway, let's now do this one. So remember, students, we will have a certain formula in the classroom, so I'm going to directly apply that one. This actually was derived from similarity property, you need to recall. So using this, everything is straightforward: x1, x2, y1, y2, r1 and r2. So it's a matter of plugging all these values in their corresponding place, and then finally you will come across with this value, that is to say x minus 1, y 0. Is this given? Yes, as you see, it is given in B. So I can say that the answer for this is going to be B. I hope you have understood everything clear.